I want to share with you guys this interesting VSD study. So this is a young lady that has a known VSD that came to the TVTI lab to quantify it. So here's the initial mid-esophageal four-chamber view. Don't really see a VSD here in the perimembranous position. Again, remember that the interventricular septum is a very complex three-dimensional separation, not just a flat wall between the RV and the LV. So you really have to angle your probe or angle your TE probe in the right way in order for you to get it. So not to fret, it'll come up more obviously a little bit later on. Here's the initial short axis view across the aortic valve here in the mid-esophageal. We're starting to see a streak here that may represent the VSD. In TE, we expect to see a perimembranous VSD in the 9 to 10 o'clock location, but remember in a TE, everything is sort of flipped. So now we go back to the mid-esophageal four-chamber view. We're starting to see a little bit more of a shunt here. We just were to twist and turn the probe a little bit more and a little bit off axis. We're able to see it here. So what I did was I started off at the view where I can see in the short axis, and I slowly turn the omni back towards so I sort of slowly turned my probe back into transitioning between the short axis view and the long axis view, so getting a little bit of an off angle view to really bring out the VSD. So here we are again. So we're doing a little bit off axis from where we used to, but here now we just little tweaking at a time. And there's a little bit movement, a little bit out, rolling my wrist a little bit, get it out a little bit more and a little bit more. So I guess the lesson here is you really have to go a little bit off axis and tweak your imaging probe to get the shunt out. So I got a nice still image of the VSD right here, very nice. And I'm getting velocities upwards of 460. I believe the outside cardiologist had gotten velocities up to 500, which is indeed a very small restrictive VSD. This is still pretty small, but remember that this person is now under sedation and has blood pressures relatively lower, so the shunting velocity may actually be a little bit lower. So one thing that I did have trouble with initially was finding, so here's the VSD again, was being on axis to find the RVOT outflow. Just remember we need the RVOT outflow and the RVOT diameter and the RVOT VTI, as well as the LVOT VTI and the LVOT diameter in order for us to find the QPQS. So initially the problem is that here in the short axis view we have our pulmonic valve, and probably we can measure it pretty well, and I did so here. I'll show you the little measurements a little bit later. So pretty good. We can at least measure the RVOT right under here at the pulmonic valve. But the problem is, how am I going to Doppler that? We're completely off axis. So I'm going to have to be a little bit creative here, so I'll show you what I did. So I'm going to start off with a gastric view. I'm going to turn it a little bit to get my five-chamber view, and I showed my five-chamber view here, and this is my LVOT outflow. I'll show you, and then the LVOT outflow VTI came up to be about 15.2. And then I turned to 90 degrees, and I turned to our usual RV view when we rotate our probe, sort of rolling pin roll it away from us, we'll get the RV, and I just tilted the probe a little bit more to get the RVOT out here. So here's your aorta and your aortic valve. You can't really see it here, but now your RVOT comes out at this gastric view, which is not something that I've done before. Usually I've been pretty lucky in being able to get in the short axis view, but here I have to be a little bit creative. Here it is again, the RVOT outflow. So I'll put all the numbers together. LVOT VTI comes up to be about 15.1, LVOT VTI comes about 15.2, RVOT diameter about 18, and LVOT diameter about 1.7. So what kind of QPQS does that give you? It gives you 1.12, so not a significant amount of shunt.